So in the previous session we have seen about vectors, vector addition, and vector addition using triangle. Then dot product of vectors, projection of vectors, and Gram-Smith orthogonalization. Okay. So now we will see the parallelogram law of vector addition. Parallelogram law of vector addition. This is same as a triangle law. Like when you want to add two vectors, let's say this is A and B. So in triangle law, what we do is we will join the vectors head to tail. So we will shift the one of the vectors so that we will get a head to tail connectivity, and resultant is given by this. Joining the first tail to last head is A plus B. And if you want A minus B, you have to reverse the vectors. Let's say this is AB, and if you want to calculate A minus B, you have to reverse the other vector and add them. So this is minus B, and if you add them, what should we do? We have to join them first tail to last tail. So this is A minus B. Okay. So now we go to parallelogram law for vectors, vector addition. So what do we do in parallelogram law? We will construct a parallelogram using the given two vectors. So we have to draw a parallel line to this. This is also same. Right, so if you draw parallel lines to both the vectors A and B, we can construct a parallelogram out of it, and one diagonal of this parallelogram will give you A plus B, and the other diagonal will give you A minus B. So this is in one shot you can, the actual operation is same as triangle law, but here in one shot you can calculate both A plus B and A minus B. And another advantage with this parallelogram law is you can calculate A dot B, dot product of the two vectors also, with this information. So that can be obtained by let's say if you calculate A plus B whole square and A minus B whole square and subtract them, you will get 4 times AB. So if you divide with 4, you will get A dot B. So this is an indirect way of calculating dot product of two vectors. So then comes the question, how to get square of the vector A plus B whole square. Okay. Right. So this is the advantage with parallelogram law. So next one, we'll see the cross product. So the basic idea we have seen already while calculating the angular momentum. To calculate the cross product, we have to take the two vectors. Let's say you are calculating angular momentum, L is r cross p in circular motion. So here the radial vector is defined from, it connects the center of the observation point to the point to be observed. So it will connect the observer to the object. So that is the direction of radial vector always. And momentum is linear momentum. Let's say the object is moving in a straight line, and if somebody pulls it in this direction, there is some force, object will fall into a circular motion. So now the angular momentum is given by r cross p. So we have to calculate this direction of this resultant. So this can be obtained by, so we have to take, we have to develop a converging pair or diverging pair from the given set of vectors. So if I shift R forward, so this will be, here you get a diverging pair. Otherwise, if you shift P downwards, you will get a converging pair like this. Then you have to look for the lowest angle starting from first vector to second vector. So you have to travel from R to P and you have to consider the lowest angle. So this is the direction of motion starting from R to P. So now the rule is, if your curl of fingers represents direction of motion from first vector to second vector, your thumb gives you the direction of resultant. Here also the same. So when the object executes circular motion in anti-clockwise direction, the resultant angular momentum is upwards. So if your curl of finger gives you the direction of motion, upwards is the direction of the vector, angular momentum vector. So let's say if you reverse the order, what happens? So instead of R cross P, if you want to calculate P cross R, so that means your first vector is P, second vector is R. Then the direction changes. So you will get a negative sign if you reverse the order in cross product. So this is R cross P and this one is P cross R. So if you reverse the order, you will get a negative sign for cross product. So now we will see gradient. So what is gradient? Gradient is an operator that studies the, usually it is a spatial variations of a scalar quantity. Like your force is a negative gradient of potential. So this gradient operator assigns sign to the assigns direction to the scalar quantity. Okay, let's say so it calculates the value of this scalar quantity at two different locations in space. Spatial variation. So this can be written as so if you consider two different locations in space and corresponding potentials are V1 and V2, so the actual operation is dou V by dou X. So means what? It is V2 minus V1 by X2 minus X1. So here you are assigning direction. This X will have a direction. So which direction you are calculating? X2 minus X1. So this is the direction you are calculating, the difference of the potential. So if that number is negative, okay, if that number is negative, that means if V2 is less than V1, then what happens? Then F is positive. So force will be in the other direction. So that means what? There exists a force always working from high potential to low potential. So force is a vector quantity. So force is a vector quantity, and potential is a scalar quantity. And this position vector adds direction to that potential. So because of this, you'll get a direction for So when you calculate this difference in one direction, you are adding a negative sign to that. So your force will be opposite to the direction of your calculation. So that's the way you convert you generate a vector from a scalar information. So gradient is the operator. So next one, curl. So let's say we'll be using this in magnetic field. So is del cross A. So here both are vectors. So here we have seen cross product of two vectors, and we are trying to calculate a cross product with del, which is dou by dou x. So what you are doing actually is this dou by dou x, dou by dou y, dou by dou z, and this is ax, ay and az. Cross product. So here also, let's say if you want to calculate the cross product of r cross p, what are you doing? So I, j, k, x, y and z, px, py and pz. This is L. So your Lx is ypz minus zpy, cross product of these two. Ly is zpx. You have to go to the next order. When you are taking x, it is yz minus zy. So when you are starting with y, it will be zpx minus xpz.
Sir,
And Lz is
similar holiday. Icon factor, sir.
Yeah. So Lz is what? You have to see the next term, xpy minus ypx. So that is how we can calculate the cross product. So here we are taking the curl, so which is a spatial variation of that physical quantity. So what you get? So here let's say this is b. So your bx x component is dou by dou y of az minus dou by dou z of ay. And by is, so to calculate y component you have to take the other two and put a negative sign. So dou by dou z of ax minus dou by dou x of az, and bz is dou by dou x of ay minus dou by dou y of ax. So what does it represent? Here az is a vector potential. So the z component of vector potential is a variation of z component of vector potential as a function of y. And the variation of y component of vector potential as a function of z contributes to bx. So if the charged particle moves in a circular path, it produces a magnetic field perpendicular to the plane of rotation. So that is what we get from this. Okay, so the vector potential is varying in yz plane, and it gives a contribution to x component of the magnetic field. just like your r and p varying in xy plane will give a contribution to z component of angular moment. Okay. So that means what? Just like this. I mean, if object is moving in this direction and there is a force perpendicular to direction of motion. If there is a force perpendicular to direction of motion, then the object comes into circular motion. So there are two perpendicular forces acting on the object. One is pushing it in the forward direction, another is pulling towards the center. So when two forces act on an object, it comes into circular motion. In the same way, you are studying the variation of vector potential as a function of other coordinates. So that means it represents the rotation of an object in a given plane, and the resultant will be perpendicular to the plane of rotation. So when curl is 0, when curl of some physical quantity is 0, that means what? You can write this as, I mean, that is what we see for conservative forces. When the force is conservative, del cross F is 0, then F can be written as some negative gradient of potential, so that del cross del V. So if you take gradient and curl simultaneously on a vector, you will get 0. So when curl of a vector is 0, you can write that vector as a gradient of some constant or some scalar. Okay, so that is how curl gives you the circular motion. If at all any circular motion exists in the system, can be studied by calculating the curl. If the curl is 0, conservation. That vector can be written as some function of scalar potential. Okay. Right. What else? So another term is divergence. Divergence is calculated for vector quantities. Here the gradient is for scalar quantities. Divergence, some physical quantity. Let's say the other term is also a vector. The result is a scalar. Divergence of a vector will give you a scalar. Okay, so what do you study there? The spatial variation of the given vector quantity. How does the magnitude varies along the three perpendicular directions of the given vector. So you are fixing the direction. So the result is a scalar. So you are considering only the variation of the magnitude along a particular direction. So once you are fixing the direction, that information will be lost. So you will be left with a scalar. That's about the divergence of a vector. And here this for the calculation of cross product, we are using right hand thumb rule. We can also use left hand thumb rule. Both are possible, both are allowed, but we have to follow any one convention. So majority of the people will follow right hand thumb rule. So this vector, which is a result of a cross product, is called pseudo vector. Because the direction is not fixed, and the direction of the vector does not incorporate any activity. So here the centripetal force and momentum are in a particular plane, let's say it is xy plane. The resultant angular momentum vector is in z direction. So the result of the cross product will not give any activity along its direction. So the entire activity will be perpendicular to the vector, and it will be in a plane perpendicular to the vector. And the direction of this vector is depends on the convention you are considering, either right hand thumb rule or left hand thumb rule. So these vectors are called pseudo vectors. I mean, that also we have seen for pseudo vectors, inversion operation will not change sign, and for polar vectors inversion operation will change the sign. And if you see the cross product of all normal vectors are called polar vectors. I mean, they will point to a particular direction, pole. So that's why they are called polar vectors. So if you multiply two polar vectors, you will get one pseudo vector. If you multiply two polar vectors, you will get a pseudo vector. And if you multiply a polar vector with a pseudo vector, you will get polar vector again. And if you multiply pseudo vector with polar vector, you will get polar vector. And if you multiply two pseudo vectors, you will get a pseudo vector. So these are the general observations when you are dealing with polar vectors and pseudo vectors. You have to confirm what are you getting while doing all these calculations. So what about magnetic field? It is a pseudo vector. And from this you can write A is equal to half del cross B. With some mathematical manipulations you can get that A is equal to half times del cross B. So what is this? So this is a polar vector, this is also polar vector, and this is pseudo vector. So here pseudo vector, polar vector, you get a polar vector as result. That is what, if you multiply a polar vector with a pseudo vector, you will get polar vector as a result. Okay. So that is how we can confirm the nature of the vectors you are going to deal with. So entire study of physics is study of the conservation laws. Identify what are the parameters that remain constant in a given phenomena, either energy, momentum, or angular momentum. So what are the things that remain constant in a given phenomena? And once you identify that, you can identify what to do next. Like in the earlier case, like bipolar pendulum experiment, we have seen energy depend, in some cases it is proportional to moment of inertia, I, and in some cases it is inversely proportional to moment of inertia. So which one should we take is decided by studying the conservation laws. So that will decide the next course of action for the system. How does it behave can be studied. So with that, I'm closing this session.